Welcome my students. We have already gone through the resistance of a conductor, and resistance is defined as the property of a conductor by virtue of which flow of current through the conductor is hindered, that means opposed, and which is measured by the ratio of current flow through any part of the conductor to the potential difference of the two ends of the conductor is called resistance. Now, resistance depends on some factors. Resistance depends on mainly number one, length of the conductor, length expressed by L. Resistance is directly proportional to the length when area of cross section remains unchanged. In a conductor, more will be the length, more will be the resistance. If area is kept constant, then resistance will be directly proportional to the length. Then the second factor is area of cross section, that is area of cross section, that is A, and resistance is inversely proportional to the area of cross section, that is more when length is constant, remaining the length unchanged. If the area of cross section of a conductor is increased, then resistance will be decreased at the same rate. So resistance is inversely proportional to the area of cross section. These are the two main factors, length and area of cross section, with which resistance is related mathematically. That is, resistance is proportional to length and inversely proportional to area of cross section. Other than length and area of cross section, there are two main factors. One is temperature and the other is material. With the change of temperature, resistance changes, and we will discuss between resistance and temperature later on. And with the change of material, resistance also changes, because one of the property of the conductor, material of the conductor, is resistivity, and resistivity of some conductor is greater and resistivity of some conductor is less. More the resistivity, less will be the conductivity, and less the resistivity, more will be the conductivity. So it depends on material of the conductor. Now from these two relations, length and area of cross section, we will get the idea of resistivity. So we will combine this length and area of cross section. Now combining 1 and 2 by joint variation, we get R proportional to L by A, or R equal to rho L by A. This is rho, where rho is a constant of proportionality. Actually, this rho is later known as resistivity, and from this relation we get rho equal to Ra by L. Now, if we consider conductor having unit length and unit area of cross section, that is, value of A is 1 and value of L is 1, then rho equal to R into 1 by 1, or rho equal to R. That is, rho is the resistance, or resistance of the conductor having unit area of cross section and unit length. Now, resistivity of the conductor is defined as the resistance offered by a conductor having unit length, that is L1, and unit area of cross section, that is LA1, at a definite temperature, is known as resistivity of the material of the conductor at that temperature. So when resistivity is measured, it will be measured at a definite temperature, and it is for a particular material. Now, on which factor resistivity depends? Resistivity depends on number one, material, and number two, temperature of the conductor. Resistivity depends on these two factors. Resistivity does not depend on the length and area of cross section, as resistivity means resistance of a conductor having unit length and unit area of cross section. So whatever may be the length and whatever may be the area of cross section, length may be increased or decreased, area of cross section may be increased or decreased, but it will be measured on the basis of unit length and unit area of cross section of a conductor. But with the change of temperature, resistivity changes, and with the change of material, resistivity changes. Resistivity of copper and resistivity of silver are different. Resistivity of silver is less than that of copper, and therefore conductivity of silver is greater than that of copper. Now, regarding temperature, I have already stated that I will discuss the dependence of temperature on resistance. How does resistance depends on temperature? Normally, with the increment of temperature, resistance increases. Resistance increases with the increment of temperature for the normal conductors like copper, aluminium, silver, etc. Temperature increases, resistance increases. But with the increment of temperature, resistance of some conductor decreases, like silicon and germanium, broaden, etc. Resistance decreases with the increment of temperature. They are called semiconductors. The best semiconductor is silicon. Other than silicon, germanium is a semiconductor, and one allotrope of carbon, fullerene, is also a semiconductor. With the increment of temperature, I am again saying the resistance of semiconductor is decreased. And the normal conductors, copper, aluminium, silver, etc., with the increment of temperature, resistance is increased. But there are some conductors whose resistance is increased with the increment of temperature, resistance will also be decreased with the decrement of temperature, but the resistance will be nearly zero at nearly absolute zero temperature. And these conductors are called superconductors. Superconductors are those conductors whose resistance will be nearly zero at nearly absolute zero temperature. The example is silicon, germanium, etc. are semiconductors. In the context, it may be stated that this silicon is used in the solar cells, and lead, mercury, niobium, etc., practically compounds of niobium, are superconductors. That is, speciality of superconductor is its resistance will be zero at absolute zero temperature, nearly. So, as resistance becomes zero, so its conductivity will be increased at an infinite rate. So, they are called superconductors. And keep in your mind that there are some conductors like nichrome, an alloy of nickel and chromium, its resistance remains almost unchanged with the increment of temperature. It is exception. Now we have learned that resistivity rho equal to R A by L. This is the formula of resistivity. Resistivity equal to resistance into area of cross section divided by length of the conductor. Now how can we get the unit of resistivity? The unit of resistance is ohm into area of cross section meter square divided by length meter. So this equal to ohm meter. So the unit of resistivity is ohm meter. Similarly, it can also be ohm centimeter. Ohm centimeter. If the area and area of cross section length is taken in CGS system, then it will be ohm centimeter. So in SI it is ohm meter, in CGS it is ohm centimeter. These are the units of resistivity. And if the resistance of a conductor having length 1 meter and having area of cross section 1 meter square be 1 ohm, then its resistivity will be 1 ohm meter at a definite temperature. And keep in your mind that this resistivity depends on temperature and material. Without mentioning the temperature, if resistivity is mentioned, that will be totally defective. Thank you, my students. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.